In this class we want to talk about the mean and median. We want to talk about how to calculate them and look at some of their properties. For example, when we multiply a series of numbers by a constant, what will happen to the mean, and how to work out the median. So it's a straightforward class, but nonetheless very important. The mean and the median are summary measures used to describe the most typical values in a set of values. Statisticians refer to the mean and median as measures of central tendency. So we often hear statisticians talking about measures of central tendency. This is what they mean. They're talking about calculating averages and the median. They're summary measures because they can summarize a whole series of numbers in just two values to work out the mean and the median, and we have an immediate picture of what the set of numbers is like. We know what the average is, and we know what the middle number is. It doesn't tell us everything about the set of numbers, but it tells us quite a lot. So it's a summary measure. It's a quick way of viewing sets of numbers if we know these two values. The difference between the mean and median can be illustrated with an example. Suppose we draw a sample of 5 students from a given class, and we measure their weights. It's just quite an arbitrary example, but let's say we just pick 5 students out of a class and weigh them, just see what their weights are. And let's say we get the following results: 58, 61, 66, 70 and 72 kilograms. So that's the weight of our students. Now, to find the median, we arrange the observations in order from smallest to largest value. So to work out the median, we have to arrange the numbers so that they're starting at the smallest and going up to the biggest. In this case, starting at 58, next one 61, then 66, 70, and then finally 72. So we've organized the weights, the results of weighing 5 students in this way, and we've organized it so we've got them in ascending order. So now we've organized them that way. If there's an odd number of observations, then the middle number is the median. So in this case, there is an odd number. We only have 5 students, so 5 is an odd number. The middle number amongst the 5 is 66 kilograms. There are 2 students less than 66, and there are 2 students above 66. So 66 is the middle value. If there's an even number of observations, the median is the average of the 2 middle values. So if we had 6 students instead of 5, then we wouldn't have a middle number. So what we do in that case is we take the 2 middle numbers, if you like, the 2 central numbers, and take an average of those. And that becomes our median. So in the example of 5 students, the median value would be 66, since this is the middle weight. Now, the mean of this, well, the mean of a sample or of a population is computed by adding all of the observations and dividing by the number of observations. So returning to the example of 5 students, the mean weight would be 58 plus 61 plus 66 plus 70 plus 72, all divided by 5, which is equal to 327 divided by 5, which is equal to 65.4. So we found the average weight is 65.4. You'll see on the sets of numbers 58, 61, 66, 70 and 72, there is no 65.4. So the average doesn't have to correspond to an actual student. It's just the average weight. It's the weight of all of the students added together and divided by the number of students. The mean can be calculated using one of the following equations. For a population, we talk about mu. Mu is the Greek letter for the average. So mu is equal to the sum of x, sigma x, divided by n. Or if we're talking about a sample, we talk about x. The sample mean is x, which is equal to the sum of x divided by n. N is, in this case, a small n because it's a sample size. So sigma x is the sum of all the population observations, n is the number of population observations, and sigma x is the sum of the sample, sigma small x is the sum of all of the sample observations, and small n is the number of sample observations. So it's just a way statisticians can distinguish between working out an average for a sample or an average for the population. If it's for the population, we have large X, and we talk about mu. Mu is the average. So mu, which is a bit like a U, except the tail on the left-hand side is slightly elongated. So mu is equal to sigma x. We add up all of the x's, all of the values, and divide by the number of values. So if we're working out the population size, let's say for a class of 5 students, and the 5 students had the above weights, we would simply add up 58 plus 61 plus 66 plus 70 plus 72 and divide by 5. And if that was the whole class, then that would be the population mean. If it was a sample out of a bigger class, we just picked 5 students randomly, we would say it's x. X is the mean, small x that is, which is equal to the sum of x, the sum of the observations, 58 plus 61 plus 66 plus 70 plus 72 divided by 5. In that case, it's a sample because we've drawn it from a bigger class. There are more than 5 students in the class. Now, the notation. When statisticians talk about the mean of a population, they use the Greek letter mu to refer to the mean score. So when we're talking about population, we talk about mu. When we talk about the mean of a sample, statisticians use the symbol x, small x, to refer to the mean score. Now, the mean versus the median. Well, as measures of central tendency, the mean and the median each have advantages and disadvantages. Some pros and cons of each can be summarized below in the following slide. The median may be a better indicator of the most typical value if a set of scores has an outlier. An outlier is an exceptional value. Sometimes when we look at, let's say, examination scores within a class, a test score within a class, and let's say we take 5 students, and one of the students, who generally speaking is quite a good student, one of the students scores 0, doesn't get any marks. That would be considered as an outlier. Perhaps there was something happened to the student on that day, or the student was not feeling well. Something happened, perhaps. But that would be an outlier, because we would not expect all the students to score 0. So if we take the median, it's not affected by outliers. We're taking the middle value. So the outliers don't affect the median calculation. An outlier is an extreme value that differs greatly from the other values. There are definitions in statistics of what an outlier is, but just for the moment, it's an extreme value. A student scoring 0 or a student scoring 100. It's very unlikely that students get precisely 100. Some do, but a lot might get 95 or 98. But scoring a perfect score, it can happen, but it's somewhat rare. However, when a sample size is large and does not include outliers, the mean score usually provides a better measure of central tendency. By and large, we talk about the mean more than the median. By and large, we prefer to talk about the mean. It's a better indicator of central tendencies. All the other scores are balanced around the mean. The mean is the middle score, the one that all the other scores are surrounding. As a measure of central tendency, the mean and the median each have their advantages and disadvantages, as I said. Now consider the following example. Suppose we examine a sample of 10 households to estimate the typical family income. So we're trying to work out what the typical family income is. Now this is in pounds, so we'll assume this is in the UK. We're only going to look at 10 households and try to work out what the average household in the UK has as an income, but that's not very realistic. There are many households in the UK. Just selecting 10 is not a good way to go about this, but just for our purposes here, we're going to select a sample of 10 households to estimate the typical family income. Now, when we do this, we find something quite extreme as well. We find 9 of the households have incomes of £32,000. 9 of them have the same income. So very extreme. But the 10th household has an annual income of £1.2 million. A lot more. So when we selected our 10 households, we found very strange figures. We found 9 of them had exactly the same income, just pretend, £32,000, and the 10th one has 1.2 million. Now if we write these down, we see here that we've got 32, 32, 32, 32, 32, and so on, and the 10th one is 1.2 million. Well, the middle number, which is our median, the middle number is 32,000. And there are more households with that income than with 1.2 million. 1.2 million is extreme. But by selecting the median, we have got rid of the extremes. So the median gets rid of outliers. The mean has been distorted as well. So sorry, the mean is distorted. It's 148,800. That's not the average income in the country. The average, according to this set of figures, will be 32, or just about 32, a bit above it, perhaps, or a bit below it. But not 148,800. And if you average all of those, that's the figure you get. So the median is a much better indicator of the true state of the figures if we have an outlier, if we have one extreme value, as we have here. So the outlier distorts the mean. That's the point. The outlier distorts the mean. Now let's look at changing units and start with the mean. Here's a set of numbers. We just picked just some numbers to work them out. We add them up, we find it's 59. We've got 10 numbers, 2, 4, 6, 8, 10 numbers. So we divide the total 59 by 10, which gives us 5.9. So the average is 5.9. The mean is 5.9. Now if we multiply each number by 6, so we'd start with 6 on the right hand side, multiply it by 6, so we get 36 on the top. Just under the x we have 36. Just under the x on the right hand side we have 6. So multiply each by 6, and if you work your way down, 6 3s are 18, 6 9s 54, 6 5s are 30, and so on. And if we do that for every number and add it up, take sigma x, we get 354. Now if you divide 354 by 10, you get 35.4. And 35.4 is 6 times 5.9. So if we multiply every number in a set of numbers by some constant, then the mean is multiplied by that constant as well. So we can see the relationship between the mean. We multiply it by 6, we multiply every number by 6, the mean is 6 times bigger than the original one. And that applies for whatever number we multiply by, or whatever the set of numbers. Now, changing the units again. Here's the set of numbers again for x. 6, 3, 9, 5, 7, so on. Added up 59. And take the average, divide by 10, 5.9. So that's our average. Now, if we add 7 to each number, this time we don't multiply like we did earlier. We just simply add 7 to each number. So 6 plus 7 is 13. 3 plus 7 is 10. 9 plus 7 is 16, and so on. If you add up the numbers on the left, each one has been added, 7 has been added to the original number. If we add it up, we get 129. Divide 129 by 10, we get 12.9. Well, 12.9 is just the original mean, which is 5.9, plus 7. So the mean is has not been distorted. By adding a 7, we just simply find the 7 turning up in the mean. Now, let's move to the median. Here's the effects of changing units. So here we have x, which is, well, sorry, let's say on the left hand side we have 6, 3, 9, 5, 7, so on. If we reorganize that on the right hand side, so we reorganize it from smallest to largest, we'd have 3, 3, 4, 5, 6, 6, 7, 7, 9, 9. So that's reordering the numbers on the left. We just reorder them because we're trying to work out what the median is. Now we have 10 numbers here, so we have an even number. So we have got just a slight little problem with working out the median here. Let's say we multiply each number by 5. So now we'd have 15, 3 times 5 is 15, 3 times 5 is 15, 4 times 5 is 20. So if you look at the right hand side, we take a 4, multiply it by 5, we get 20 on the other side, on the left hand side. And if we take the the median, which was 6, 6 is the middle number, we find the median on the left hand side is 30, which is just 5 times 6. So multiplying by 5 has not distorted the numbers. It hasn't changed the fundamental relationships that are going on. The median is still in the same place. It's in the right place. It's in the center where we calculated it originally. It hasn't moved by virtue of us multiplying by 5 or multiplying by any number. If we add 4 to each number, so we'd have 3 on the right hand side at the top, plus 4, which is equal to 7 on the left hand side. The next one is 3 plus 4, 7 again. Next one is 4 plus 4, which is 8 on the left hand side. So we've added 4 to each number. Now, in this case, the median is 10. That's the middle number. So we have 2, 4, 1 is 5 on the bottom and 4 on the top. Well, that's because we've got 2 10s here as the middle numbers. So the median is 10, because if we take an average of 10 plus 10, the average of 10 plus 10 is just 10. So we leave it as where it is at 10. Now, if we take that across, we'll find it's the same on the other side, 6, which was the median we had before. So adding 4 has not distorted the median. It hasn't moved the position of the median. It's still smack in the center. It's still in the right place. Adding 4 to it has not upset the median. So multiplying by a number or adding a number, we just have to allow for the fact that the figures may be different or will be different, but they're in the same position. It hasn't distorted the fundamental relationships in the numbers. Now take an example. Say 4 students scored the following grades in a maths test. Say they scored 84, 86, 91 and 97. Now these are ordered from smallest to largest. 84, then going up to 86, going up to 91, going up to 97. So someone scored 97 out of 100. That's a very, very good result. So what we need to do is work out the mean score and the median score. That's the task we're asked to perform. Well, the mean score is just 84 plus 86 plus 91 plus 97 divided by 4. There are 4 students. And the mean score is 89.5. So that's the mean score. You'll note, of course, there is no 89.5 on the original scorecard. There's 84, 86, 91, 97. There's no 89.5. So the mean does not have to correspond to an actual number within the set of numbers we're dealing with. It's just the mean. To calculate the median, we must find the central number. In this case, there are an even number of values. There are 4. There's just 4 students, so there's an even number. And we want the middle one. We want the median, which is the middle. The median is the average of the 2 middle values, which is the average of 86 and 91. So add 86 to 91, divide by 2, which is 88. So the median is 88. Again, it doesn't correspond to any number in the original set, but that's the middle value. That is the value at the middle. And it doesn't take into account the 84 or the 97. So if they were outliers, they would not distort the figures. The median would still be 88, because we're only dealing with the central 2 numbers, 86 and 91. So that's all we're going to deal with in this straightforward class, talking about the mean and the median. So let's leave it at that and say thank you for watching.